Localization. Resource files. Setting up and using resource files is a primary means of localizing programs. Resource files are specialized binary files that can be bound to a standalone DLL or added into a program assembly. They contain strings, graphics, and other binary resources that assist in localizing a program. Creating a resource file. The Resource Generator utility, ResGen, is a string resource creation utility that comes with the Microsoft .NET Framework SDK. Given a properly formatted .txt text file, ResGen converts it into a .resources binary resources file that can subsequently be added to an assembly. Without a special resource creation tool, string resources begin life as a specially formatted .text file. They have headers, comments, and name-value pairs. Header elements must match the file name without the extension. For example, if the resource file's name is myresources.txt, the header contents must be myresources. Comments are useful for delimiting groups of resource strings or adding more information to the use of a string. All comments are removed from compiled resources. Writing a resource file. Resource files may be created programmatically. This is useful for automated .resources file generation utilities or resource tools in IDEs. The steps involved in creating a .resources file are to open a resource writer stream, add whatever resources are needed, and then close the stream. The default resource writer class in the system.resources namespace implements iResourceWriter. This is why it is possible to create an iResourceWriter object within the main method of the resource writer constructor. It accepts a string parameter specifying the resource file to create. If a file by that name exists, it will be overwritten. Reading a resource file. The resource reader class is also useful in creating resource manipulation utilities and IDE tools to manage resources. A utility uses the resource reader functionality to read in an existing resource file. The program performs any necessary manipulations, and then the resource writer helps write the new resources back to the persistent .resources file. Converting a resource file. Another use of ResGen is to convert between .txt, .resources, and .resx files. REXX files are XML format files used for binary resources such as graphics, fonts, icons, and cursors. For example, the following command line converts the .resources file to a .resx file. ResGen strings.resources strings.resx. This produces an XML format file. The same exact file would have been generated if you had performed the following command line. ResGen strings.txt strings.resx. Creating graphical resources. The .NET Framework SDK includes a couple of sample programs that help manage graphical resources. One is the RESX Gen program, which adds a graphic file to a .resx file. The RESX Gen utility. The RES Editor utility. The other is the RES Editor program, which manages all types of resources for .resources files. Using graphical resources. An added bonus is that these two utilities come with a source code, enabling you to examine graphical resource manipulation code in detail. Multiple locales. The purpose of resource files is to support multiple locales. The official way of specifying locales is via cultures, as specified in RFC 1766, ISO 639, and ISO 6133. Cultures are denoted with 4-character designations. The first 2 characters specify the language in lowercase, and the second 2 specify the country or region in uppercase. A separate resource file must be created for each locale. There are multiple ways to deploy these resources: compiled into a program, via satellite assembly, or via global assembly. Multiple locales. Through a combination of resource files and a directory structure geared toward targeted cultures, any program can be localized. The directory structure corresponds to each culture implemented in a program. The following directory structure supports localization for a program named multiculture: EN, ENUS, ENGB. If the appropriate culture subdirectory is present, a localized program can automatically pick up the resources corresponding to its default locale. Finding resources. Search the global assembly cache for the specific resource. The global assembly cache functions as a central repository for all programs on a machine to access. Search culture subdirectories of the localized program. Search the global assembly cache for parent resources. For instance, if the original resource selected but not found was an ENUS, search the global assembly cache for EN only. Search culture subdirectories of the localized program for the parent resources. Search culture subdirectories of the localized program for parent resources of the last parent resource searched. A resource has only a single parent, but the chain of parents can extend to multiple levels.